Here we're looking at example 1 from our 2.4 number 1 set of notes. Now before we dive into this though, let's go ahead and look at what the definition for a slope-intercept form is. This is something that we've probably already seen in the past, but again I want to be thorough and actually have that formal definition of what it is. Slope-intercept form is pretty much your y is equal to mx plus b, where m is your slope and b represents your y-intercept. Alright, so now how that's going to actually help us out is we're trying to write an equation of a line that's parallel with this line and also passes through this point, this other point, -4, 5. Well, in order to get something to be parallel with this guy, we first have to find the slope, because then we want to use that same exact slope. So we're actually going to go ahead and try and solve for specifically y here. We would accomplish that by actually going ahead and subtracting this x from both sides. We end up with -2y is equal to -x plus 4. Since we want y by himself, we're going to go ahead and divide both sides by -2. -2's end up canceling out on the left side, leaving us with just y is equal to. When we divide this -x divided by -2, we end up with, really there's a number in front of this x. If it's not written there, it's assumed it's a 1. So ultimately we have -1x divided by -2. And then likewise with this 4, we can go ahead and just divide those as well. So we end up with plus 4 over -2. Now, kind of just simplifying things up a little bit, we end up with -1 divided by -2. We have a negative divided by negative, that's a positive. So really we have 1/2 x. And then 4 divided by -2 just gives us -2. Now, we really didn't have to worry too much about finding this specific value, this -2. But that's okay, because again, it's really nice practice just to kind of be thorough and putting it into that slope-intercept form, that y is equal to mx plus b. So now, let's go ahead and use the parallel slope with this line. Well, if it is in fact parallel with this line, we know that they have to end up coming out to be the exact same slope. So what we're going to do is use that slope of 1/2. It also says that we're trying to write an equation of a line that passes through this other point, -4, 5. So it's passing through -4, 5. So we have a slope, and it also passes through this point. Well, how can we write an equation of a line that would satisfy those conditions? Well, if you think for a moment, if it's passing through this point, we end up with some x and y value. Now, using our slope-intercept equation, we can go ahead and we have y is equal to mx plus b. We can actually go ahead and throw in our m, since we know what he is. That's 1/2. We also have an x and a y, so we can even throw those values in. So over here we have 5. Our x is -4. We have no clue, though, what this b value is. So right now he's still just b. And the goal here is to solve for b. So we end up then with 5 is equal to a half of -4, it just comes out to be -2, plus b. Adding 2 to both sides, we see that b comes out to be 7. So now we've actually gone ahead and done all the hard stuff, all the hard parts. So this was all the hard stuff. But again, our goal is to write an equation of a line that is parallel with this other line. Well, we know that they had to have the exact same slopes for two lines to be parallel with one another. So we have y is equal to 1/2 x. We've also found that b value for our slope-intercept form. So now all we have to do is really just throw that value in. So we have plus 7. And in fact, here is our other line that is in fact parallel with this other line. Notice they have the exact same slopes, different y-intercepts. And that should be happening for two lines to in fact be parallel with one another. Notice same slope, different y-intercept. Let's go ahead and very just quickly graph these. Our first equation was 1/2 x, 1/2 x minus 2. And again, here is that line. For our other line, we have 1/2 x plus 7. There now, as you guys can plainly see, are our two parallel lines. Again, same slopes, different y-intercepts. So again, that is the definition for slope-intercept form and example 1 from our 2.4 number 1 set of notes.